Okay, so here we go. Do you recognize this figure? What kind of figure do you think this is? How many sides do you see on the face that is on the top?
8.
8. Pardon, sorry, again?
Octagonal prism.
That is right. It's an octagonal prism. And how do we know this? Because if we count the sides on the top, this is what we get. We get 1, 2, 3, 4, 5, 6, 7, 8 sides. So yay, as the face of the prism has got 8 sides, we can say that we can call this figure octagonal prism. This is a prism that has a face of 8 sides. So if they were asking us to find the volume of this figure, the only thing we need to do is to use the same formula that we have been using, okay, in pentagonal prisms, in hexagonal prisms. Which formula? The one that says that you first need to find the area of the base and then times the height of the figure. So let's imagine that this figure had the following measures. 10 meters tall, from here to here 5 meters, and then as a value of the apodema, imagine that it has 3 meters. That is the value of the apotema. So if we wanted to find the volume of this figure, we need to do the general formula for polygons of more than 5 sides, which is perimeter times apotema divided by 2, and then times how tall my figure is. So how do I find the perimeter of a figure of 8 sides? Who can tell me?
You add them all.
Exactly, you add them all, or which is the same, you multiply the value of the sides times 8, so that gives 40 meters. So you can either do 5 plus 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 5, or which is the same, 5 times 8. So the volume of this figure then is going to be given by the 40 meters, that is the perimeter, times the value of the apotema. What is the value of the apotema of this figure?
3.
Exactly, times 3 meters, that divided by 2, and then all that times the value of the height of the figure, which is 10 meters. So volume then is going to be given by 120 divided by 2 times 10. The volume then, 121 divided by 2 is 60 times 10, and that is going to be 600 meters cubed. Always the units for volume are cubic units. So just to prove that no matter how many sides we have on the prism, it works anyway, the formula of perimeter times apotema divided by 2. Okay, just for your info, at the end of the session, I'm going to be asking randomly for the notes of some of you. So you better be prepared. And leaving the session not to show me the notes is not an option. Okay? Actually, that's rude. Did everybody follow what we are doing?
Yes.
Okay, can you think about real life examples of octagonal prisms? To be honest, not really. At least not me. What can you think of?
Like a pool can. Or a jacuzzi.
Okay, could be.
A weird shaped can.
A weird shaped can. Actually, there is a cake that they sell in December. I saw it in Soriana and HEB that comes in a box, a cardboard box, and it was a shape related to that. Yes, Regina?
Once I was at a friend's house and we and all the girls like ordered a pizza from another place and it came with a like an octagonal box.
Seriously?
No.
Do you remember the place?
No, but I think it was a special day or something.
Oh, wow. It's interesting. We always get rounded pizza, so nice.
Teacher, I cannot draw the octagon. Like,
Yeah, I know. One tip that not always works, but it could be a tip, is to first do the part of the top, and then you do the body. So that's the only tip I can give you. I totally get it because I'm a terrible drawer myself. So if you do first the parts of the top, and then you do the body, there you get a kind of prism, you know. It's not easy to make this ones. I totally get it. The figures that are coming for us are easier. Can I move my screen? Can I clean it so we can go and get a new picture? Yes?
yes.
Okay. So now we're going to talk about cylinders. There is homework for this week related to cylinders. So yay, let's have fun with cylinders. They are easier in all ways to draw. So the first thing I'm gonna ask you is there a shape that reminds you of a cylinder in real life?
A can.
Yes, it could be a can. What else?
A
A
trash
glass
can.
of water.
Trash can. Sorry, what else?
A glass.
How do you write that?
GLASS.
Like this?
No, glass.
No,
Like
glass. I didn't follow what you were saying. Yay. Thank you.
and also this thing that I have, I don't know how to name it.
What is it? Show us.
It's to put like your pens or stuff like that.
Oh, okay. Your pen container. What about lipstick? Don't you love lipstick?
Yeah.
I've got a lipstick that looks like that. Cylinders in real life. So this is a cylinder, or it could also be called, but it's not common at all to hear, circular prism, because it belongs to the family of the prisms. So you first say the name of the base and then you say the body. So how do we find the volume of cylinders? The formula is the same. We are going to do area of the base times height. Exactly the same formula for all the prisms. The only thing is to make sure we know the formula for their bases. So the area of a circle, because the base of this figure is a circle, all this is a circle. So how do I find areas of circles? Who remembers?
You do 5 times 5, like 5 to the second power. And then times 3.14, I think.
And the reason, very good. The reason of that is because areas of circles are equal to pi times radius to the second power. So if the value of the radius is a 5, you take the 5 to the second power and then times 3.1416, which is a short version of pi, okay? because the pi, to be honest with you, has 200 decimals. Did you know that? On March 16, which is 3 and 16, the month 3, day 16, you and I will talk about the pi day, and we're going to talk about all the truth that is behind pi. Okay. So 5 to the second power is 25. 3.1416 times 25, that gives 78.54 millimeters to the second power, because in that part, I'm still dealing with the area of a circle. So the volume is going to be equal to 78.54 millimeters to the second power times the 6 millimeters of the height. So finally,
Sure, didn't we just use like just 3.14?
yes, but we can do that for the class, but then you will go to Alex, and Alex is going to force you to get 3.1416.
No, teachers, because I already did the homework like for today, and it tells you 3.14, not.
Me too.
Seriously? In the other classroom, the problems that they got were with 3.1416. Okay, fine.
Teacher.
Yes?
I don't understand very well. What does it say after, like, the brackets after the 78.54?
I get it. Here, it's a 6 millimeter thingy. Sorry, it's the height of the figure. Once you have found, is it better now?
Yes, thank you.
Yes. Once you have found the area of the base, which in this case is a circle, you multiply that area times how tall your figure is. Is everybody following what we are doing? Isa, the camera. Thank you.
Teacher, can I go to a restroom fast?
Yes, ma'am. Okay. Can I move my screen so we can get another picture?
No, teacher, I'm almost done.
Okay, don't worry, we can wait. Carmen, do you have your computer already?
No, it's my mom. She lent it to me.
Oh, okay. And when are they going to give it to you, honey?
I don't know, but I want it like now. I need it so much. It's like I really need it.
I know, we depend on it, right?
Yes.
Can I move my screen now?
Yes.
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 Okay, another one.
Teacher, can I go to a restroom?
Yes.
Thank you.
Okay, so the same thing. We're going to find the volume of this cylinder. And the formula is volume equals to area of the base times height.
Teacher, that's also a circular prism.
Yes, or cylinder. Better. It's a cylinder. Shifted, but cylinder. So the area of the base, as it is a circle, is going to be pi times radius to the second power. So who can tell me what values I'm supposed to insert?
3 to the second power, 9.
Yes, and then that times pi. The value of pi could be 3.14 or 3.1416. Pau Treviño, the camera. Pau Treviño, the camera.
Oh, teacher, I was in the restroom.
Okay.
You told me to.
Claudia Leal, the camera.
She went to the bathroom.
Okay. (28.26 meters to the second power is the value of the area. So I come here and I do 28.26 times 6 and this is what I get as a final answer. Did everybody get it?
Yes.
Can I move my screen?
I have a question, teacher.
Of course.
Why does it say, like, why is it a 2? Like radius 2, why is it a 2?
It's part of the formula since forever. It's radius to the second power. So if the value of the radius is 3, 3 times 3, and then whatever you get times pi. You are using PEMDAS. Parentheses and exponents are done first, and then multiplications and divisions. So you first take the 3 to the second power, and then that times pi.
So it's always gonna be 2, like it doesn't depend on the figure.
It doesn't, well, yes, it depends on the circle. It's a circle. So formulas of circles are pi times radius to the second power. This formula is the area of the circle since forever. You take the radius, you multiply it times itself, and then times pi.
Okay, thank you.
Let me know if I can clear my screen